if you ever have any chemistry problem, I have gazillion textbooks on my bookshelf. Please come and ask me.
A synthesis reaction is the joining together of two reactants or compounds to produce a complex product, also called a compound. A good way to remember this is think of the word combination, since multiple reactants combine to make a single product. The general formula for synthesis is A plus B produces AB, A and B being the reactants, and AB being the product. You can predict what forms in a synthesis reaction by simply looking at the reactants. Here are 3 examples. 1. Reactions with oxygen. When an element combines with oxygen, it creates an oxide of the element. Iron reacts with oxygen to make an iron oxide. 2. Reactions of 2 nonmetals. When 2 nonmetals react, they form a covalent compound. Water is an example. Hydrogen plus oxygen makes water. 3. Reactions of metals with nonmetals other than oxygen. When a metal and nonmetal react, they often form an ionic compound, usually a salt. Sodium and chloride combine to form table salt.
Our reactants are calcium oxide and water. Upon combining the two, there is a synthesis reaction where calcium hydroxide, a base, is formed.
Chemical decomposition is the separation of a chemical compound into elements or simpler compounds. You can think of it as the exact opposite of chemical synthesis. The general formula is AB produces A plus B. The stability of a chemical compound can be limited when exposed to extreme environmental conditions, like heat, radiation, humidity, or the acidity of a solvent, therefore causing decomposition. Here are some examples. Metal chlorates decompose when heated. A metal chloride and oxygen gas are the products. Carbonates will also decompose when heated, a notable exception being that of carbonic acid. Carbonic acid, or the fizz in sodas, will spontaneously decompose over time into carbon dioxide and water.
Our reactant is cobalt chloride hexahydrate. Place a fair amount on the tray. Turn on the hot plate to max. We will be observing a decomposition reaction. The red cobalt chloride hexahydrate decomposes to cobalt chloride, which is blue, and water vapor.
A single displacement reaction is a chemical reaction where a pure element replaces an element in a compound to form a new product. So cations will replace cations and anions will replace anions. This can be shown by the general formula AB plus C yields AC plus B, where both AB and AC are aqueous. So as you can see, element C has replaced element B to form a new compound AC and the free element B. The reactants will always be a pure element, such as hydrogen gas, combined with an aqueous compound. Combining these reactants does not mean that a reaction will always occur. To determine that, we must look at the activity series. The reaction will only proceed if the element that replaces the original element is more reactive. Let's look at the reaction between zinc and HCl. As we can see, zinc is higher than hydrogen. Therefore, it will replace hydrogen in the reaction, forming zinc chloride and hydrogen gas. Although, if we were to combine silver instead of zinc, the reaction would not occur.
Our reactants are solid magnesium metal and aqueous hydrochloric acid. When combined, a single displacement reaction occurs, where products of magnesium chloride and hydrogen gas is made. This is because magnesium can displace hydrogen on the activity series.
Double displacement reaction is a type of chemical reaction in which two reactants exchange ions, forming two new compounds. This can be represented by the general formula AB plus C yields CB plus AD. Here's an example. Sodium sulfide reacts with hydrochloric acid to form sodium chloride and hydrogen sulfide. As you can see, the two cations, so the sodium and the hydrogen, have switched places. The products are always one of three options. The first is a precipitation. So that means you will have one solid and one aqueous compound. The second one is a gas production. This means that you will have one gas and one aqueous product. The last option is a reaction that produces water.
Our reactants are iron 3 chloride and sodium hydroxide. When combined, a double displacement reaction occurs. The products are sodium chloride and iron 3 hydroxide.
Combustion usually occurs when a hydrocarbon reacts with oxygen to produce carbon dioxide and water. But if we're being more general, combustion involves a reaction between any combustible material and an oxidizer to form an oxidized product. Combustion is an exothermic reaction, so it releases heat. However, at times a reaction may be so slow that a temperature change is not even noticeable. There are two types of combustion. The first is complete combustion. Complete combustion reacts oxygen with a fuel to produce carbon dioxide and water. Since the air we breathe is only 21% oxygen, a large volume of air is required for complete combustion to take place. In other words, there should be more than enough oxygen to cause all of the carbon to turn into carbon dioxide. When a fuel undergoes complete combustion, it releases the maximum amount of energy from the fuel being reacted and is usually characterized by a blue-colored flame. Here is the general formula. Hydrocarbon plus oxygen gas produces carbon dioxide gas plus water vapor. A specific example would be the combustion of methane. On the other hand, incomplete combustion takes place when a combustion reaction occurs without a sufficient supply of oxygen. It is usually characterized by an orange-colored flame. Here is the general formula. Hydrocarbon plus oxygen gas produces carbon monoxide gas, carbon dioxide gas, water vapor, and soot. Incomplete combustion is often undesirable because it releases less energy than complete combustion and produces carbon monoxide, which is a poisonous gas. Using a similar example as before, here is the incomplete combustion of methane.
Our reactant is acetylene gas and oxygen gas. Acetylene gas is made by the reaction between calcium carbide and water, which is a double displacement reaction. By inverting a test tube filled with water, you can trap the acetylene gas as it is created. Upon lifting it, place a stopper and don't allow the gas to escape. Grab a lit splint, undo the stopper, bring them together. This is an example of incomplete combustion, as other products are created. Reactions happen all around us. Today we're going to see some types of chemical reactions that happen in our everyday life. Barbecue. Did you know that every time you cook that delicious meat, you're using coal, which is carbon, and combining it with oxygen? You form carbon dioxide. That is a synthesis reaction. After cooking that delicious barbecue, you might want a calming drink. Grape juice is turned into alcohol by the process of fermentation. Grapes on the vine are covered with yeast, mold, and bacteria. By putting grape juice into a container at the right temperature, yeast will cause the sugar in the grape juice to decompose into alcohol and carbon dioxide. The grape juice will have fermented into a lovely drink. Next time you have a glass of wine, thank decomposition. In the industry are often found in mines as ores. Ores are usually oxides, alloys, carbonates mixed with sandy impurities. To extract pure iron, a mineral called hematite, iron oxide, is combined with coke, a type of carbon. They are combined at high temperatures. With this single displacement reaction, pure iron and carbon dioxide is formed. Sometimes you feel a little sick, and you can feel your stomach bubbling with the excess of stomach acid, also known as hydrochloric acid. You take one of these. Calcium hydroxide, often referred to as an antacid, undergoes a double displacement reaction with the hydrochloric acid to neutralize it. It forms calcium chloride and water. Fun fact, this is a special type of double displacement called acid-base neutralization, but we'll leave that to someone else. Your gas stovetop is a very simple example of combustion in your everyday life. When you turn the dial, natural gas, most often methane, but can also be propane or butane, is released from the gas supply pipe under your house. As it reaches the top of the stove, it combines rapidly with oxygen. As you can see, it is a blue flame, indicating complete combustion. You can adjust the flame height by turning the dial, which releases more gas. I always knew combustion was my favorite.